Hello everyone, welcome back to my organic chemistry course. This video will mark the beginning of Unit 3, in which we will cover everything you need to know about acids and bases as they relate to organic chemistry. This chapter is really cool because we will actually introduce our first type of reaction and learn how to diagram these reactions for all future chapters. In this video, I want to give an overview of the different definitions we have for acids and bases, and how they're used in organic chemistry. The first definition I want to cover is arguably the most important definition for organic chemistry: Bronsted-Lowry acids and bases. The Bronsted-Lowry definition describes acids as proton or H+ donors, and bases as proton or H+ acceptors. For example, your hydronium ion, H3O+, is a Bronsted-Lowry acid, since it could give away one proton, while the hydroxide ion, OH- is a Bronsted-Lowry base, since it can accept one proton. The next definition I want to cover is the Lewis definition of acids and bases. This definition is important because it can help understand some reactions as acid and base reactions when the Bronsted-Lowry definition doesn't quite make sense. A Lewis acid acts as an electron acceptor, and a Lewis base acts as an electron donor. To remember Lewis acids and bases focus on electrons, I like to remember that Lewis structures always include lone pairs. And drawing Lewis structures is super important for being able to see electrons moving around between acids and bases. The last definition, and probably the least applicable of the three to organic chemistry, is the Arrhenius definition of acids and bases. Arrhenius acids produce H+ ions when dissolved in water, while Arrhenius bases produce OH- ions when dissolved in water. The reason we don't focus much on this definition in this course is because it only describes acids and bases in an aqueous environment. However, you should still know what this definition is in case you get a question about it on your exam. Among these three, the Bronsted-Lowry and Lewis definitions are the most important. With Bronsted-Lowry acids and bases, we can visualize a reaction and understand what moves around when this happens. We'll focus on the explanation for these reactions, called mechanisms, later. For now, we need to remember that unlike your previous chemistry courses, the acids and bases we work with are most often not straightforward. In other words, they won't 100% form a product. To describe these type of acids and bases, we call them either strong or weak. You may remember your list of strong acids and bases. In organic chemistry, we will see reactions that do not show full dissociation. Because of this, the product formed can technically move back into reactants. To label this, we like to call the product of an acid a conjugate base, while the product of the base a conjugate acid. To remember this, imagine the other side of the reaction going left. Which one would be the acid, and which one would be the base? To practice labeling Bronsted-Lowry, Lewis, and Arrhenius acids and bases, check out the practice problems linked below. Try them out and compare your answers to the answer key. For additional help, watch the explainer video also linked below. In this video, we talked about our definitions of acids and bases. In the next video, we'll learn how to explain reactions between acids and bases and introduce a pattern of diagrams that we will use for the entire course.